Hello guys, welcome back to my YouTube channel. We were discussing about gradient. Till now we have discussed what is gradient, how it is defined, and I have also told you a trick to solve any gradient problems involving R, the position vector, and we have also discussed the physical meaning of gradient. What is the physical meaning of gradient? It is nothing but when we take a surface phi, the gradient of phi is nothing but the normal vector to the surface of the phi at a given point. So the formula to solve for unit normal to the surface at point P is given by n cap is equal to del phi divided by absolute value of del phi. We also solved several problems related to unit normal vector. These were very interesting problems. Now I'm gonna discuss about a small subtopic, a concept, which is the extended version of the normal vector. The topic is angle between two surfaces. So this is quite logical when we think of any two surfaces like this. Suppose this is surface 1, let's call it phi 1. This is surface 2, phi 2. The angle between them is given by, how can we find this angle theta? Just draw a normal to this point of intersection from this surface, and for this surface draw another normal to add this point, like like this. So this angle between n1 and n2 gives the angle between the two surfaces at this point P. So how can we write angle between any two surfaces is given by n1. How can we solve for angle? Taking the dot product, right? Let's take dot product of n1 and n2, which gives absolute values of n1 n2 times cosine of angle between them. What is n1? Gradient of phi. I have told you this in the physical meaning of the gradient. Phi 1 at the particular point P dot gradient of phi 2 at a particular point P is equal to, taking the mod values, gradient of phi 1 at P times gradient of phi 2 times P times cos theta. So cos theta is equal to del phi 1 P dot del phi 2 P whole divided by del phi 1 absolute value P times del phi 2 P. So only this is such a small topic. We'll just move on to the problems now. Taking the problem, first problem, find the angle between the surfaces x squared plus y squared plus z squared is equal to 9 and x squared plus y squared minus z is equal to 3 at 2 comma minus 1 comma 2. So let's solve this. What is the first surface? First surface is x square plus y square plus z squared minus 9 is equal to 0, and second surface is x squared plus y squared minus z minus 3 is equal to 0. Taking the del of phi 1, we get del of phi 1, we get 2x I cap plus 2y j cap plus 2z k cap. Del phi at that particular point, what is the point? I'll write it here. Point is 2 minus 1 comma 2. So at this point, when we substitute 2 into 2 is 4 I cap minus 2 into minus 1 is minus 2 j cap plus 2 into 2 is 4. I'll write it directly, 4 k cap, and absolute value of this is del phi 1 p. Absolute value is under root 4 squared plus 2 squared plus 4 squared is equal to, I'll write it directly, 4 squared plus 4 square, 16 plus 16 32, 32 plus 4 36, root 36 is 6. Okay, now del phi 2 is given by 2x I cap plus 2y j cap minus k cap. Del phi 2 at that point is 2 into 2, 4 I cap minus 2 j cap minus k cap, and this is, and del phi 2 p's mod value is under root 4 squared plus 2 squared plus 1 squared. What we get? 4 squared 16 plus 4 20, 20 plus 1 21, so it is root 21. Now what we have all the values. Cos theta is equal to del phi 1 at p dot del phi 2 at p divided by absolute value of del phi 1 p times absolute value of del phi 2 at del phi 1 p dot del phi 2 p is equal to 4 into 4 16 plus 4 minus 4 is equal to 16. So cos theta is equal to 16 divided by 6 root 21. When we cancel this, 2 8s are 16, 2 3s are 6, so it is cos theta is equal to 8 by 3 root 21. So theta is equal to cos inverse 8 by 3 root 21. This is the final answer. By this way, we can find out the angle between any two surfaces at a given point. So let's move on to the next problem. Question: what is the value of constants A and B so that the surfaces ax squared minus byz is equal to a plus 2 times x will be orthogonal to the surface 4x squared y plus z cube is equal to 4 at 1 comma minus 1 comma 2. Options are an MCQ question. A is equal to 3 by 2 comma b is equal to 1. Option B, A is equal to 5 by 2, b is equal to 1. Option C, A is equal to 7 by 2, b is equal to 1. D, A is equal to 9 by 2, b is equal to 2. So pause the video first, try, then match the answer. Surfaces are given by phi 1 is what we have, x squared, I'm writing it directly here, minus a plus 2 times x. I am bringing this side, so the calculation becomes easier. Minus byc is equal to 0. That is surface 1. Surface 2 is given by phi 2 is 4x squared y plus z cube minus 4 is equal to 0. Let's so take the gradient of both the functions. It becomes, now we have to be careful, we have to first write the definition of the gradient first. Del x of is phi 1 plus j cap del by del y of phi 2 plus k cap del by del z of, this is phi 1, sorry, I stand correct, this is phi 1 and this is phi 1. So del of phi 1 is differentiate this function with respect to x, treating all the other variables as constants. So we get 2ax minus a plus 2 I cap plus, now treat x and z as constants, only y as variable, so we get minus bz j cap plus, now treat only z as variable, we get minus b y k cap. If we put the point, substitute the values of the coordinates here, we get what is coordinate. I'll write it down here first. P is equal to 1 minus 1 2. Substituting the values, we get 2a into 1 is a minus a plus 2 I cap plus minus b into z is 2 j cap minus b into y is minus 1 k cap. So we get del phi 1 at point P is equal to, I am writing it directly now, a minus 2 I cap minus 2b j cap plus b k cap. Now what will be del phi 2? We get, differentiate phi 2 with respect to x first, then y, then z. We get 8x y I cap plus 4x squared j cap plus 3z squared k cap. Now what we have been given in the question is that del phi 1 at point P and del phi 2 at point P. Let's evaluate that point P first. Point P, phi 2 at point P. Evaluating, we get minus 8 I cap plus 4 j cap plus 12 k cap. Now what we have been given in the question is that the surfaces at this point P is orthogonal. Orthogonal means 90 degree. That means the dot product of the vector del phi 1 and del phi 2 is 0, because how we defined the dot product, vector n dot vector n2 is equal to n1 mod of n1 times mod of n2 times cos theta. When theta is equal to 90, that means when n1 and n2 are orthogonal, cos theta will be 0, so the dot product will be 0. So it is given in the question that del phi 1 dot del phi 2 is 0. So simply we have to just find the dot product first. So how to find the dot product? Del phi 1 p dot del phi 2 p is equal to 0. To find the dot product, just multiply the coefficients of I cap here and add with this. So we get minus 8 times a minus 2 plus 4 times minus 2b plus 12b is equal to 0. This implies minus 8a plus 16 minus 8b plus 12b is equal to 0. This implies 4b minus 8a plus 16 is equal to 0. Taking the things common, we get 2a minus b is equal to 4. So we have to check the options separately which satisfy this equation. I think the first option is, let's take the first option. First option A is equal to 3 by 2 and B is equal to 1. So 2 into 3 by 2 minus 1 is equal to 2 to cancel. 3 minus 1 2, so is the wrong answer. Let's check for B. B is A is equal to 5 by 2, B is equal to 1. 2 times 5 by 2 minus 1 is equal to 2 to cancel. 5 minus 4 1 4. So B is the right answer. Checking C. A is equal to 7 by 2, B is equal to 1. 2 times 7 by 2 minus 1, this becomes 6, so it is also wrong. D. A is equal to 9 by 2, B is equal to 2. So 2 times 9 by 2 minus 2. 2 to cancel, 9 minus 2 is 7. So this is also wrong answer. So the right answer is B. I hope you like this video. I'll zoom out now. I hope you like this video. If you like this, please like, share, comment, subscribe. This entire playlist is dedicated to vector calculus. There will be more videos coming up, so stay tuned and thank you.